Okay, so once again, good evening all. So we'll start the session. So initially, we'll start with the introduction to the vCenter. And generally, when we speak about the virtualization infrastructure, so initially we need to understand about what is virtualization, why we want to get into virtualization. So these are the basic things we need to understand initially. So after understanding why we want to get into virtualization and the benefits of virtualization, so then we will move on to the further discussion about what is virtualization and so on. So generally, traditionally we use our on-premises data center, that is the physical server for physical data center, where we'll have all our servers as a physical servers. But coming into the virtualization technology, so basically the virtualization technology helps us to create multiple virtual machines on top of a single physical server. So generally the industry standard where you'll have multiple servers, and also the recommendation is in one particular server it is always recommended to have only one service. For some cases, we used to have two services or three services. Say example, if we have a Active Directory domain controller, so where we'll have Active Directory service and DNS service together. But most of the cases, say example, if I have a SQL database, so where I'll have a dedicated server for that. If I have a DHCP server, or I have a print server, or I have a file server, for these kind of services, we used to have separate servers for each services. So generally, the industry standard is one service per server. So configuring too many services in one server is not recommended. So that's why we used to have too many servers in our physical data center environment. But when we speak about a physical data center environment, say example, for my project, I require around 20 services. So obviously I should have 20 servers. So if it is a physical environment, obviously I should have 20 physical servers. But having 20 physical servers, obviously the investment on purchasing of the servers is going to be high, and the space required to keep all the 20 servers is going to be high, and the power consumption and uh, mm, 24 by 7 power supply and several other aspects are there. So basically, running a data center, the operating cost is going to be high if it is a physical data center environment. Uh, but since we have 20 physical servers, whether all the 20 physical servers are efficiently utilized, so that is one more important question. So speaking about the utilization, it is not that all the servers are going to be 100% utilized. So the utilization is going to be very less comparing to the virtual infrastructure. Speaking about the uh, utilization, first of all, we should understand how the hardware is getting utilized, or how the hardware is getting driven. See, generally, when you have a physical hardware, on top of that, you'll have the operating system installed. On top of that, you have your application installed. So basically, the end user is going to work on the end user application, whatever the application might be, maybe a Word document or an Excel file or a Tally software or whatever. So the end user is going to work only on the application software. But whatever the command executed, or whatever the options that is clicked by the end user, so behind the scenes, when a user is clicking an option print, so basically, when you press on the print button, so on the back end, a set of code is going to be executed. A piece of code is going to get executed, which means that some instructions are executed behind the scene. Okay, so when I click on the print button, some instructions are getting executed behind the scene. Whether these instructions are directly given to the hardware, not exactly. See, generally, the application software is basically uh, the language that is used for developing the application software that cannot be understood by the physical hardware. So basically for driving the physical hardware, or for giving the instructions to the physical hardware, so we used to have assembly language, so where this kind of language can directly communicate, or it can directly give the instructions to the hardware. So the instruction to the hardware is going to be in a different language, and the input from the end user is going to be in a different language. So someone should be there to uh, uh, convert this kind of instructions. So basically, in your computers, it might be a desktop computer or a server computer, you'll have the kernel. I believe you might have aware about the kernel. So kernel is the core of an operating system. So basically, the core has the required instructions which can directly instruct the hardware. So whatever the um, hardware you have, so the hardware is going to be driven by the kernel of the operating system. On top of the kernel, you'll have the operating system. On top of the operating system, you'll have your application software. So whatever the instructions executed in the application level, so that instruction is given to the operating system. So where the operating system gives the instructions to the kernel, and then the kernel gives the instruction to the hardware, so that the hardware performs the respective task. So basically, this is how a computer works. So in general, the hardware is going to be driven by the kernel of the operating system, and it's up to the capability of the kernel how efficiently it can utilize the hardware. Just with a simple example, you may drive any vehicle like maybe a two-wheeler or a four-wheeler. The vehicle may have a top speed of 150 kilometer per hour, but as a rider or a driver, you might have driven the vehicle maybe up to 120 kilometer per hour, but the vehicle has the capacity of 150 kilometer per hour, but you have driven only 120 kilometer per hour. And even in the 120 kilometer per hour, you might not be consistent for up to certain distance. You might drive in 40 kilometer per hour. Maybe after a certain distance, you might drive in 60 kilometer per hour. So whenever you are inside the city, so you cannot reach the top speed of 120 kilometer per hour always. So maybe due to the road conditions or due to the traffic, there are several other reasons over there. So the vehicle has the capacity of 150 kilometer per hour, but still the driver, maybe again the capability of the driver, uh, he might not able to reach the 150 kilometer per hour due to several other reasons. So in the same way, the hardware utilization, that is the kernel, how the kernel is efficiently driving the hardware, it's again going to vary based on different conditions or different criterias. So generally, if it some cases, we may speak about some heavily loaded services like email service or a database service. So these kind of services are basically heavily loaded services. See, generally, when you want to configure any service or a server, so initially we'll have a capacity planning before choosing the server hardware, the server model. So basically we'll uh, uh, decide on the server configuration, how many processor the server should have, how much of RAM the server should have, how many hard disk the server should have. So the planning, basically we call it as the capacity planning. So in what basis we'll plan the capacity? So again, based on the requirement. So basically the capacity planning will be based on the requirement, how the capacity is going to be planned according to the requirement. Say example, I'm going to configure an email server. Okay, first of all, you need to decide, that is the technical team should sit with the management team, and they should have a discussion about what product they are going to use. Say example, you may have a Microsoft Exchange server as an email product. You may have a Zimra, or you may have a Lotus Domino, or you may have a Postfix. So several email applications are there. Out of these, what you are going to use for your organization, for your environment. So basically, being a technical person, so you'll explain about the features of each product, and based on the features, maybe not only based on the features, maybe based on the cost also, there are several factors. So where the management team may decide which product will be suitable for their environment. Say example, where the company management has decided to choose Microsoft Exchange server as their product. Okay, so now the product is finalized. Okay, after choosing the product, so we need to consider about on what operating system this Exchange Server application is going to run. Maybe it is going to run on top of Microsoft Windows Server. Okay, for running the Windows Server operating system alone, so what is the memory is going to be consumed, or what is the CPU amount of CPU is going to be consumed. So basically, running the operating system alone, it's going to consume some part of some amount of CPU and some amount of RAM. So basically, first you need to consider this consumption. So you need to consider about the CPU utilization and memory utilization of the operating system alone. On top of that, you're going to run your application, that is your Exchange Server application. For running the Exchange Server application alone, how much of CPU and memory is going to be consumed? That has to be uh, understood. Okay, how do you know this? How do you know the resource utilization of the, say, operating system and the application? So basically, your vendor should give this. Microsoft operating system, obviously, Microsoft is going to give the resource consumption or resource utilization of the operating system alone. And similarly, for Exchange Server, again, Microsoft is going to give you the resource requirement to run the application alone. Okay, I have, say example, for running the operating system alone, it requires 1 gigahertz of processor and 1 GB of RAM. And on top of that, for running the Exchange Server application, it requires a 2 GB of RAM and a 2 gigahertz processor. Okay, so total requirement is now 3 gigahertz processor and 3 GB of RAM for running OS and application alone. On top of that, you're going to create mailboxes for the users. Okay, how many users this particular server is going to serve? Okay, again, the management will give you the numbers, maybe 1,000 users. And as a support professional technical person, you should have a long-term plan, 3-year plan or a 5 years plan. Again, you should question your management that. So 1,000 users is current users, or after 1 year, what will be the number of user? After 3 years, what will be the number of user? After 5 years, what will be the number of users? So based on that, they can plan accordingly. Okay, for example, currently they are saying I have 1,000 users, so you plan for 1,000 users. Okay, for 1,000 user, again, we need to calculate the single user consumption. When one particular user is connecting the email server to access the mailbox and he is sending and receiving the emails, for that alone, what is the amount of CPU and memory that is going to be consumed? Again, Microsoft will give you the requirement. So generally, when you're configuring email server as a MAPI client, where it requires minimum 3 GB or 3 MB of RAM per user, sorry, 5 MB of RAM per user. If you're configuring your client as a POP3 client, so where 3 MB of RAM is enough. So based on how the user is going to access the email server, so based on that, Microsoft will give the recommendation. So based on that, you can plan accordingly. Say example here, the company is going to use all the user, or they want to provide the MAPI client access. So maybe 5 MB RAM per user is required. Okay, 5 MB RAM. Okay, I'm going to have 1,000 users. So obviously I'll have the requirement of 5 GB. So when my server has 8 GB of RAM, so that will be sufficient for running the mailboxes for 1,000 users. Maybe another 10 more user or 20 more user are connecting. Obviously, the server will not have enough resource to serve the end users. So based on this, you can have the calculation. Generally, the company will have 3 years or 5 years plan. Okay, maybe the company is saying that after 5 years, the employee count will be 3,000 employees. So obviously your server configuration should be 3 times higher. So obviously you'll go with the 24 GB of RAM. So that's how you can accommodate the capacity, accommodate the load uh, over the period of time. So this is how the capacity planning will do the capacity planning. Okay, we'll just understand with a simple example. I want to configure mailbox for 1,000 users. So you just have a server only for 1,000, accommodating the 1,000 users. So I have a server with 8 GB of RAM. And similarly, I have planned all the other resources like network resource or hard disk and also the CPU and all the things. So assume I have a server configured with Exchange server and I have configured mailboxes for all 1,000 users. All the 1,000 users are concurrently accessing the mailbox. So which means that the server is at peak utilization. Under this peak utilization, what do you think the resource overall resource utilization might be? Can anyone of you give me your opinion? I'm just waiting for your response.
So, sorry, I lost the question.
See, I have a server configured with Exchange server, and I have configured the mailboxes for 1,000 users, and my server capacity is optimally uh, designed for only 1,000 users. That is it has only the resources to serve only the 1,000 users.
Okay,
So all the 1,000 users are concurrently accessing the mailbox. So what would be the overall resource utilization of that particular server?
it will be a performance issue will raise.
No, no. My question is, what will be the utilization, overall utilization in percentage?
Obviously, 100%, right?
So obviously
Because
it should be 100% because we have the plan, we have
capacity.
planned only for the 1,000 users and we have the neck to neck resource. Obviously it should be 100%. But originally the resource utilization will be only between 35 to 40%. That is because of the capability of the kernel. Just a while before I was explaining about the capability of the kernel, and there are several other aspects which reduces the performance or which doesn't allows the kernel to consume the 100% of the resource. So generally in this kind of peak utilizations, the hardware utilization will be overall between 35 to 40%. And there was a survey on the hardware resource utilization of the data center servers globally. The survey was taken globally, and the result of the survey was the utilization of the servers, the physical servers, was only between 5 to 15 percentage. It varies case to case, but the overall utilization of the data centers globally, it is only between 5 to 15, 15 percentage. So here we were speaking about a server that is heavily loaded server, that is the Exchange server. Even it is able to consume only 40% of the resource to the maximum. Think about the services like a print server or a DHCP server. So these are all the lightly loaded servers. So obviously the hardware utilization is going to be very, very less, maybe between 3 to 5% or 8%. So the very big uh, issue in the physical data center is the hardware utilization. So the hardware is not efficiently utilized. So basically here we need a solution to efficiently utilize the resources, whatever the available resource that should be efficiently utilized. See, say example, in a data center, I have 10 servers. End of the year, the management is asking the utilization report. So your utilization report will say, example, I'm going with the maximum utilization of 40%. So out of 10 servers, only 4 servers are utilized and the 6 servers resources are not utilized in theory. In practical, obviously, all the 10 servers are running, all the 10 services are serving the end users. But in theory, the overall utilization report says the 6 servers are not utilized. So this underutilization is eating the profit of the project or profit of the company. So this virtualization technology basically it comes as the uh, solution for the underutilization. So basically, as I said earlier, the utilization is only between 5 to 15% of the overall uh, data center resource. And here, coming into the virtualization, so basically it is going to efficiently utilize the resource. Okay, how the resources are going to be efficiently utilized? See, traditionally we have one physical server. On top of that, we are running one operating system, which means that only one kernel is running. The kernel's capability is maybe only between 35 to 40%. If I am able to run multiple kernels on the same physical server, obviously the underutilized resources can be consumed by the multiple kernels. So basically this virtualization allows you to run multiple virtual machines with independent operating systems, that is independent kernels. So where the virtualization technology is going to allow you to run multiple kernels concurrently on the same physical server, so that the hardware utilization is going to be high. So since the hardware is efficiently consumed, so where the additional resource requirement is automatically brought down, so that obviously it saves your cost, not only the investment as well as the running cost also. Is that clear for you all? If you have any questions or any doubts
So, so,
related.
so if you are going to have a physical server,
Mhm.
and in physical server, it will be very difficult to run multiple application, which will cause kernel panic and other thing. Is my
Exactly,
understanding
exactly. Because there is only one kernel is running or one kernel is serving for all multiple applications.
correct? So wherein in the virtualization, it will be a individual kernel, even though it is running on one physical machine.
Exactly, exactly.
Okay, okay, right. Thank you.
You're welcome. And now we need to understand what is virtualization. Before getting into understanding the virtualization, uh, we were just speaking the term like virtual machine. On top of a single physical server, you can create multiple virtual machine. Now here, the question is arising is, what is a virtual machine basically? Okay, before understanding about a virtual machine, speak about a physical computer. What is a physical machine? What is a physical computer? Basically, a physical computer will have a motherboard, CPU, RAM, hard disk, monitor, and all the stuffs put together. We call it as a computer. So, which means that a physical computer is collection of physical hardware parts. And now coming to the virtual machine. What is a virtual machine? Again, virtual machine also is going to have all these hardware parts. A virtual machine is going to have its own CPU, its own RAM, its own network interface card, its own hard disk, its own BIOS. All the hardware which a physical computer has the similar hardware parts the virtual machine also is going to have, but in the form of files. So a physical computer is a collection of physical hardware parts, where a virtual machine is a collection of virtual hardware files. When you create a virtual machine, a set of files is going to be created. So when you create a virtual machine, for that particular virtual machine alone, a virtual hard disk is created, a network interface card is created, a CPU is created, similar like this, all the hardware is created. Okay, when you speak about a RAM, for a RAM, there will be a file. For a hard disk, there will be a file. For a BIOS, there will be a file. So like this, a virtual machine is a collection of virtual hardware files. Is that clear for you all? If there is any more
Yes.
questions, please let me know. Okay. And here I want to explain you about the virtualization with another presentation. Okay, so now we'll start understanding about what is virtualization. And I believe my uh, new presentation is visible to you, right? The presentation which has a physical server, RAM, disk, and
Yeah,
NIC. Or okay, see, you can assume this is a physical server, and the physical server has a CPU, RAM, disk, NIC, and all the hardware parts. And here, on top of this physical server, I'm going to create virtual machines. So basically, the virtual machine also is going to have all the hardware parts. It is also going to have the CPU, RAM, disk, and NIC. But the physical server will have all the hardware parts as the physical hardware, and the virtual machine is going to have all the hardware parts as virtual hardwares. And on top of the okay, and also here we should understand about few terms which you need to use the same terms whenever you speak. So when you speak about a virtual machine, use the term exactly virtual machine, or you can use the term VM. Don't use any other term. Maybe some people may use the term virtual server to represent this unit. So this is not basically a virtual server, because it is not that in virtual machine you will be running server operating system always. You may also run a desktop operating system also. So never use the term virtual server. So basically this particular unit, we call it as a virtual machine, or you can call it as a VM. Don't use any other term. And on top of the virtual machine, you're going to install the operating system. And the operating system installed on top of a virtual machine, you always call it as a guest OS. So guest OS is the exact term which is to represent the operating system which is running on top of a virtual machine. And generally, the entire unit or the physical server, the physical box in which you run your virtual machines, we can call this physical box as a physical server or a physical host, or you can call it as a hypervisor host. Okay, we'll discuss about what is hypervisor later. So initially, to when you want to mention a particular system or a server running with a virtual machine, you always call it as host, or you can call it as physical box. Don't use any other term, or don't use the term virtual server or something like that. Got it? Is that clear for you all?
yeah,
Okay. So here I have a virtual machine. On top of a virtual machine, I have installed the guest operating system. It might be a Windows operating system or a Linux operating system, whatever maybe which is the compatible platform, x86 platforms, any operating system you can install. And on top of the operating system, usually you install your applications. See, generally, as just a while before, I was explaining about a user who is working on the applications. So he is choosing some option. Maybe he is selecting the option print. So basically, the hardware should respond to it. It should print something, or it should print whatever it is intended for. And the end user is clicking on some option on the back end. Some instructions are executed. So basically, the instructions are given to the operating system, and the operating system kernel understands the instruction, and it converts the instruction to the hardware language, and the instruction is given to the virtual hardware. That is here I'm mentioning it as virtual CPU. So the instruction that is given by the end user through the application, that is given to the virtual CPU by the kernel of the guest OS. And since this is the virtual CPU, it cannot execute any instruction by itself. So it has to depend on the physical CPU. So basically, the instruction which is given to the virtual CPU, the same instruction is given to the physical CPU. And now here, physical CPU will understand the instruction, and it will execute the instruction, and it will process the instruction, and it will respond back to the virtual CPU. And obviously, the virtual CPU will respond back to the operating system, and operating system will respond back to the application. So basically, this is how the virtualization works. So where the virtual hardware, it cannot work independently. So it should depend on the physical hardware to process any instruction, to execute any instruction. Maybe through the operating system, maybe some information might be stored in the RAM of the virtual machine. So the information that is stored in the RAM of the virtual machine, that is basically going to be stored in the physical RAM. It is going to consume the space of the physical RAM. Similarly, whatever the file is stored in the virtual hard disk, that is going to be stored in the physical hard disk. Maybe any data that is transferred through the virtual network interface card, that is going to be transferred through the physical network interface card. So all the virtual hardware is going to depend on the physical hardware to complete the process. Is that clear up to this? If there is any questions, please let me know. Okay, I consider there is no question. So here, uh, we need to think about two things. One is we should be able to create a virtual machine, which means the virtual files has to be created. We need some software program using which we should be able to create the virtual machine. And after creating the virtual machine, that is after creating the virtual hardware, there should be some interlink between the virtual hardware and the physical hardware. There should be some communication established between the virtual hardware and the physical hardware. So to do this, we need a software program. So basically the software program is called as the hypervisor. So hypervisor is basically a software program using which you can create virtual hardware, and also the hypervisor software itself is going to be uh, responsible for establishing the programmatic connection between the physical hardware and the virtual hardware. So basically the hypervisor program, it creates the programmatic link between the virtual hardware and the physical hardware, so that whatever the instruction given to the virtual hardware, so that can be carried out by the physical hardware. You can understand something like mapping. So this particular hypervisor maps the virtual hardware with the physical hardware, so that whatever the instruction given to the virtual hardware, so that can be immediately responded by the physical hardware. So basically this is how the virtual machines is going to function. And I said we need a software program, that is the hypervisor. Using the hypervisor, you're creating the virtual hardware, and the hypervisor itself is responsible for establishing the programmatic connection between the virtual hardware and the CPU, the physical hardware. And this particular process, which is creating the relationship between the virtual hardware and the physical hardware. So this particular process is called as virtualization. So basically the virtualization is not hardware or a software. Basically, virtualization is a process which is going to be done by the hypervisor software. So hypervisor software is doing the work. What work it is doing? It is doing the work of virtualization. Basically, what is the virtualization is? It is nothing but the mapping of the virtual hardware with the physical hardware, so that whatever the instruction given to the virtual hardware, so those instructions can be handled by the physical hardware. So this is basically the virtualization is. I hope you got a better understanding about what is virtualization. If you have any more questions, please let me know. I'm waiting for your response. Guys, are you able to understand what is virtualization? Okay, okay, there is no questions. That's great. Fine. Okay, so when we speak about virtualization, so basically there are four important components. So that is going to be considered in the virtualization. So that is a CPU, a RAM, a network, and then the disk. So these are all the four major components which is going to be considered in the virtualization. And based on the functionality of these four components, so the virtualization is going to work. And nearly all the products, Microsoft product or a VMware product or a Citrix product, or it shall be any hypervisor product. So these are all the four components. So that is going to be considered in the virtualization. And further, we'll also understand about the uh, types of virtualization, and we'll also understand about the virtualization products maybe in the next class. So in tomorrow we'll be discussing about the types of virtualization and the other topics. And in the topics whichever we have discussed right now, if you have any questions or doubts, please let me know.
So this is Surendra.
Yes, Mr. Surendra.
Yeah, virtual VM using any conception of memory.
See, basically for running your hypervisor, it requires some amount of CPU and memory, but based on the virtualization type you use, if you're going, there are basically two type of virtualization: hosted virtualization and hostless virtualization. So when you're going with a hosted virtualization, where for running your hypervisor alone, it requires more CPU and memory. But when you're going with the hostless virtualization, that is the bare metal virtualization, where the consumption of CPU and memory is going to be negligible.
Okay, it's used to. There is any issues in end user sites. It's
See,
let
basically for every virtual machine, you're going to allocate some amount of RAM. So basically, again, for your virtual machine, again, you need to have the capacity planning as you, as I explained in the beginning. So you need to do the capacity planning. So for your virtual machine, what service you are going to run for that particular service or the application, what is going to be the CPU or memory required. So based on the requirement of your application, so you need to allocate the required amount of RAM to your virtual machine. So if you are allocating the required amount of resource to your virtual machine, obviously there won't be any performance issues. But
okay.
if you miss this resource calculation, if you fail in the capacity planning, obviously you're going to face the resource issues. Got it?
Yeah, yeah, got it.
The very important thing is the capacity planning.
Yeah.
Okay. Any more questions? Okay.
Yeah.
So if there is no more questions, so this is going to be the end of the session, and we'll discuss the remaining topics in the next class. And thank you all for joining the session. Bye bye. Good night.
Good night.
Thank you.